Welcome folks, back to the Thermoquad carburetor for today. Today I'll be talking a little bit about the secondary air door or air valve, call it what you will. It's big enough that you can't miss it. What happens here is you're able to put a much larger cubic CFM carburetor, cubic feet per minute is what it's measured in. Underneath you can see just how large these are. They can put something like this is about an 850 CFM carb on a small block engine, a 340. I don't even know if they go down to a 318 as far as Chrysler products are concerned, but anyways, you can put a much larger carburetor like this on because of this air door. What it does is it restricts the amount of air entering there so that you won't get that big lean bog thing going on. If it wasn't for that valve and you ran it with that fully open, you'd just get a big wallop of air going into your engine, and it wouldn't pick up enough fuel to make the correct mixture, and it would just probably start to backfire and give you all kinds of headaches. So that's the reason for this, and there's just so many adjustments you can do to this thing. It's incredible. I'll start with a few basic ones for today. Aiming mostly at say a stock engine, small block. Perhaps you have headers on it, dual exhaust, that's fine. Problems start when you have radical cams and deep breathing engines where vacuum is low, say at idle. But I'll leave that for another time. But today we'll concentrate on mostly stock applications. Alright, for starters there's a spring in here. I probably showed you on a previous video. And I'll explain how that works. This shaft goes all the way excuse me, from here where the choke pull-off connects to. Right in here. This little part in here. What can we call that? A curved slotted bracket. It's it's fixed right on the shaft. It runs right through here and it stops a little bit short. There's these two hex-headed screws that fix this air valve plate right onto the pivoting shaft there. And in here I can perhaps explain it without taking it apart. Like I say, previous videos explained it and what it looks like inside. So I'll just go over it briefly. Like I was saying, the shaft that controls this air valve is fixed on. It stops a little short, and then there's a spring in there. This is just for an example. It's much larger than the one that's in there. It's quite a bit smaller, and the coils are wrapped tightly together. They're not spaced apart like this, but just to give you an idea how they work. With this shaft stopping a bit short, it's fixed onto this end. And on the other end, you've got, much like in here, not considering the lockup mechanism, it looks like a big nail head. Just a common nail with a flat end on it. Only it's got a screw slot in it for adjustment. It's not a screw when you look into the end of this thing. In the middle there, it looks like it could be the top of a screw, but it's not. It's much like I say, a nail head without any threads on it. It's just so it can spin and make the adjustment for you. So the other end of that spring is connected to that thing that looks like a screw but doesn't have threads, so that you can lock it in place once you've set the adjustment, and then you can set the torsional force on that spring. So what's happening, that spring is underneath where you can't see it. It's on the underside of the air horn. If you take the top off, you'll see it. So anyways, what's happening when you're pushing down on there and you feel that spring tension, you're basically torquing that spring. Some people call it tension, but I guess the proper word you're looking for is torsion, because it's a torsional force. So you're actually, this end is fixed with your adjustment, and the end of this shaft is connected to the other ends of the spring. So when you're pushing that air door down, you're twisting that spring like this. This end is fixed, and you're turning that spring, right? So you can adjust that spring torsion to suit the required needs of either the way you want the car to launch, how rich or lean you want it to run. But that's basically it for the setting part of it, to get an explanation to you so you can see clearly what's going on underneath here. So I'll set that aside for now. Okay, so let's start with, everybody wants to really know how to set the spring tension on these things. On the end here, like I was just describing, that thing that looks like a screw head inside, is just it's a plain shaft, and it connects to the end of that spring that's inside here that I was giving you an example of over there. And this outer one has got 2 notches in it, and what it is a threaded ring, and there is a special tool, like this is the lock ring here, the outside part, and the inside part that looks like a screw is the adjustment. There is a special tool you can get. I'm pretty sure there's some aftermarket ones. If you'd have a hard time trying to find an original, I guess, from the factory, but there's aftermarket ones that are on the internet you can find that'll fit that. It's basically the one that was actually designed for this. It's like a hollow tube or a pipe, if you will, with a T-handle on the end, and on the end there's 2 protrusions that fit into these 2 notches of this lock ring. But I never had one. The thing you got to watch too is, if you don't have one, is not to chew this lock ring up. I put my hand up, I've done it. But what I've done since that point in time is I got an old screwdriver that I had not doing much around, laying around in the shop, and this one I was fortunate enough, it was soft enough that I could file it. So what I did is I cut the end off and I filed it down to size, so I got a really nice fit in here in that lock ring. It fits really good. There's hardly any movement in there at all. So if you're going to use the screwdriver method, try to find an old one and grind. If it's too hard to file, then you can grind it to size, or if you find one, fortunate enough like me, find a larger one that you could actually file it down to sizes. That's what I did with a big file, is just kept on filing. Like I say, cut the end off with a hacksaw to get the width, and then file it down, and then until it fit the slots. So when it comes to the final tightening of this thing, you can get it good and tight without ruining those slots on the lock ring that's there. So I'll just give you a quick and easy way to do it. If you're unlocking it for the first time, go easy. You don't want to uncoil that spring too quick. So try to do it as slow as you can, and just nice and slow until you see the air valve start to drop like that. If you do it too fast, I don't know if you might do harm or dislocate the spring on the 2 shaft ends inside. So that's getting it loose. Now, in order to set this thing, some of them will work this way. You just snug them up very lightly, just to create a bit of friction on the inner adjustment screw. And the setting I remember, like, you look up in your specifications for your particular application for your vehicle, but one that I remember adjusting for was 1 1/4 turn. But to get the 0 point on this thing, what you want to do is bring the air door up against this boss that's cast in the top air horn. It actually stops right here. So you're winding the spring tension up counterclockwise until that air valve just touches there. And then from there you crank in the number of turns that you require, according to your specifications and or your personal needs. So I'll just start going here. Naturally need a smaller screwdriver to get into that adjustment screw. So I've used the friction method I was telling you about. If that doesn't work, you can get a smaller screwdriver and you can just push on the slots. Try not to chew them up too much. You might want to make sure you don't damage too much. But depends, like sometimes there's a free spot, sometimes there's a friction spot. Depends on how it was made, your particular one. So as you can see, the air valve's starting to come up there now. Most people, they might just go until it touches, but a better way to do it would actually poke on it a little bit and watch what it does. I actually put a drop of oil into the shaft here to make sure there's no friction binding. You'll find if they're dry, it's supposed to be Teflon coated shafts, but you could get wear or crud in there. You want a really nice smooth feel if you're ever doing maintenance on these things. So you just basically bring it up until it touches. Go back and forth a few times and poke it with your finger until you get it to where it's just touching. And there it is there now. So I'll crank in an additional 1 1/2 turns. Sorry, 1 1/4 turns. There's half, 1 1/4. Now if it's not going to stay there, you can, this one is going to stay, I was fortunate, but you can just get another little screwdriver while holding this one and then just push it till it's snug. Like I say, you don't want to be hammering on there or anything, you'll destroy the little slots in that lock ring. And then this one's staying put, so I just get the screwdriver I custom filed for this fit, get in the lock slot, and just tighten it up and make sure that the adjustment screw slot didn't move when you did that, and it looks like it stayed, so I've just cranked in 1 1/4 turns on that torsional spring in there. I found out that setting for my particular vehicle worked really well, but you can adjust it a little less, little more. Don't like crank in 4 or 5 turns, you'll end up with a choke effect. This thing won't want to open freely enough, and it'll hold back, and you'll be drawing too much fuel as opposed to air. If you adjust it too light, this will come in too quick. Well, you still got to consider the choke pull off and what it's doing there, but it will come in quicker once the vacuum drops if you have a lighter spring torsion adjustment on here. So I would start with the stock setting. Look up the specifications for your particular application, your engine and whatnot. Start there. So the one I remember is 1 1/4 turns for me anyways. Okay, there's that set. It's fairly easy once you get the hang of how that works. Another one, you can control how rich or lean it is once it hits the full stop. Now there's on this little plate that fits in over some of the air bleeds in here with a single screw. On the one side there's you can probably see it. There's a little stop finger that comes out. On this side there isn't one, but over here there's a stop. Now right here on the air valve there's a slot. There isn't one on this side, but this is the adjusting side here where the slot is. That's what controls the amount of stop. If you bend this little corner tab of the air horn and you make so those dimples on the secondary door go closer to the spray bars, meaning opening wider, it's theoretically you would get a leaner mixture. You never want to go too lean with an engine, because that's when you start cooking valves, putting holes in pistons. So really watch your how lean you go. If anything, go a little bit rich. It's a safer way to go than it is to go lean. So the stock setting I recall is measured at the back of the air horn here, the choke wall air horn. From there, it's measured to the edge of the air valve itself. The measurement I remember was a 1/2 inch for the particular application that I was doing. Look up your specifications. That's a good starting point, and then you can tailor it to your needs as necessary. With that, just bending this corner piece here in the air valve, like I say, it hits this little stop finger on this bracket. So this one is measured up. So I've actually taken out the metering rod tree out of here so you can see clearer. If that wasn't gone, you'd have trouble understanding, maybe seeing what's going on. So I got a steel scale here. So that one measures a 1/2 inch from the back of the choke tower wall, whatever you call it, to the edge of the air valve. That's those 1/2 inch. So for me, that would be set as a starting point. Like I say, you can adjust that as required for your own application. Okay, so there's 2 of the adjustments. On to this other end here. There's I'd mentioned it in another video, I believe. This is just sort of put together for demonstration purposes. That's the actual big washer and the little fancy retaining clip that the Chrysler folks use. So when you pull this back, there's another adjustment. For high vacuum stock engines, like I'm going to explain here, when this is fully retracted, you can do it with vacuum, or just hold it in is good enough, as long as you got it held back square and you're not touching this connecting rod. With that held back, let's center it up a little bit for you. There should only be about a 32nd of an inch play there. You wouldn't want to go too tight, because then you'd be restricting. You should always have a little bit of clearance in there. I would say leave yourself a 32nd of an inch, as long as you got a tiny bit of play in there with this the choke pull off fully retracted. That's a really good starting point for stock engines. There's other people say you can bend this linkage and have a lower down starting point, but then it affects all your other settings as well. There's a sequence that you have to do when you're setting up the choke and the fast idle cam, so take that into consideration if you go that route. But for stock engine, you basically just just have a 30-second clearance between where the air valve and the casting boss is here. So those are those three adjustments. There's another thing I'll mention while I'm at it. I notice there's sometimes a time when this gets a little bit sticky in here, where the lever connects into that that curved slot in the control bracket there for the end of the shaft of the air valve. There's a thing I did with it. I was driving a small block with a standard transmission, and I remember seeing just how it would run. Found myself, I put my foot into the gas pedal, and the way we went, the revs it wouldn't even really come up, it just started popping and everything. And what I discovered is it's very important to keep these, I'd probably mentioned in a previous video, keeping these choke pull-offs here fresh. Once those rubber diaphragms in there start to harden up, and you know, they start to they get a little bit stiff and sticky with old age. This one doesn't even come out very good. It actually comes out on an angle. A good one should come straight out. But what happened in that time when I was doing that full throttle application is this choke pull-off got stuck. So now the air valve can't open up, and boy oh boy was it ever making a fuss. It was just gurgling and stuff. It just would not go. It just sounded sick. I didn't like it at all. So enough of the full throttle for that day, and I started to think about it, and I thought, well, before I go out and buy a new choke pull-off, I'll just try the other way. See, I live in Canada here, so I gotta still have the choke. So what I came up with is I took this linkage out of here so that we would have it all free for the air valve. Some people say, oh, you need this because it's going to bog on you and stuff. Well, with a 4-speed I can get my revs up before I drop the clutch, and away I go. And so what I ended up doing was eliminating this linkage, and I bent up my own custom one, made it up so it's a bit shorter. I drilled a hole. This is the actual lever that controls the choke pull-off, the plate here. In a colder climate you have to have a choke. Your car just won't run without it. So I ended up drilling a hole in the choke arm here and made up a shorter linkage so it would just actuate the choke linkage, that's all, and it wouldn't do anything for the secondary air door. And I thought, well, here it comes Bog City. So I went out and took it for a drive. Boy was I ever surprised. It's never run better. Just make sure that everything is really smooth feeling here. If you decide to keep it the standard way that the factory intended, especially with an automatic, you probably need that, especially if you don't have a high stall torque converter. All of a sudden you open up those big secondary air valves and you don't have any revs in your engine yet. You're down 1,000 or 1,500 RPM, and you put the big gulp in it, and it probably will bog on you. But with a standard or a high stall speed torque converter with an automatic, I would definitely try it without the linkage on the shaft that controls the air valve. Give it a try. If you don't like it, you can always put it back on. No big deal. You don't even have to bend the custom linkage up like I did. Just take it off after the engine's been warmed up and go take it for a test drive. And if you don't like it, put it back on. Nothing lost. Didn't cost you a cent. So that's what works for me. I've run it without, just as long as you got the choke linkage working. You need that cold climate, but I've just left it off, and I found even without any adjustments at all, I just kept the stock adjustments, the 1 1/4 turns on the spring wind up, and then the 1/2 inch setting on this back of the choke wall here, and keeping the air door 30-second, just a little bit of clearance there on the stop. That's all I set it, and boy, I tell you, it's torquey. It never backfired, nothing. It was just solid. So that's what works for a standard transmission for me. You go ahead and experiment with what works for you. I just hope that what I've told you today can help you out. Don't be afraid to try a few things as long as they're not dangerous or illegal. So that should get you started on understanding how these the secondary air valves or air doors work. Just keep it nice and smooth here. If it's excuse me, it feels sticky, it's not going to work right. It's got to be smooth. So this one is really smooth. A few drops of oil. You're inside the air cleaner anyway, so you're not going to really get any extra dirt in there anyway. So some people say never oil your throttle shafts. It's going to make more dirt. But then you've got dry on dry, and that creates friction. Especially on this one, you keep it smooth, and it'll reward you down the line with some good performance. So there you have it. Take care, have a nice day, and bye for now.